So number 17 here, it says in the picture below, the density of the liquid is 1 gram per milliliter. What can you tell about the objects and their density? It says since the block is floating, there's a block up here. Since the block is floating, its density is less dense than the liquid. It's saying since the oval is sunken, its density is more dense than the liquid. And it says the liquid has a density of 1 gram per milliliter. Where would something with the same density be? And it would be floating somewhere in the middle. So we'll say in the middle. So it says circle the elements in the list below and box the compounds. So we're looking for elements. Those are going to be our one set of capital letters. So Na is sodium, N is nitrogen. This has more than one set of capital letters, so that's going to be a compound, C6H12O6. And then CO is cobalt, so that's an element. C is carbon. Carbon dioxide is a compound, 2 capital letters. H2O, water, that is a compound. Cu is copper, that is an element. NO3, compound. NaHCO3, that is also a compound. So number 19 here, it says elements cannot be separated chemically. And then compounds are elements combined in definite proportions. So for example, water here, it's a combination of elements and there's 2 hydrogens for every 1 oxygen. So that's the definite proportion. Number 21 says in the boxes below, draw a picture to represent an element in one box and a compound in the other box. So when I'm thinking of elements, I'm thinking they're the same shape, same size, but they're all exactly the same, and they're not combined. Now a compound is going to be a combination of those, and they're chemically combined. So I'm drawing, this could be an example of like H2O, where it's got 2 hydrogens for every 1 oxygen. So this would be an example of a compound where it's these combined. Now 22 says the picture shows a chemical reaction. During a chemical reaction, a new substance is formed. How can you tell a new substance was formed during this reaction? So if we're looking at this, we're looking for some evidence of chemical change. What I see is a bunch of bubbles here. So a gas is produced. And that's the evidence that I'm looking for that a new substance was formed. Now number 23, it says identify each of the following examples as either potential or kinetic energy. Place a P in the blank for potential and a K in the blank for kinetic. So potential, remember, is stored energy. And kinetic is energy in motion. So the spinning blades of a fan spinning tells me it's in motion. That's going to be kinetic. Now this is a picture of a guy about to jump off a cliff. Looks like he's going cliff diving. He hasn't moved yet, so that's going to be potential, stored energy. Because once he jumps, then it'll transform into kinetic. Running uphill, maybe running slower, but they are still moving, running. That's kinetic. Now these are raindrops falling. They're in motion, so it's kinetic. A ball resting on the ground. That's potential. And then this is a picture of a guy pulling back a slingshot. That's potential because that elasticity right there is making the object want to go forward, but it hasn't started moving yet. So it's potential. So the next question says, how can you tell if an object is gaining or losing kinetic energy? So we tell this by the object's motion. So we said when the object is slowing down, it is losing kinetic energy. When the object is speeding up, it is gaining kinetic energy. Number 25 here. As hot air balloons rise higher and higher into the air, what type of energy increases? So we're looking for the type of energy that increases as it's going up. As it goes up, it's getting further and further from the ground, which increases the potential energy. Okay, number 26, it says, identify the type of force seen in the pictures below. So we've got balanced and unbalanced forces. So if the forces are balanced, that means it's not going to be moving. It's got no motion. If it's unbalanced, that means one force is pushing harder on an object, pushing or pulling harder on an object. So that means it's going to be in motion. So the book's falling off of the bookshelf, that's unbalanced, because these books are in motion. These books are standing still. That's got balanced forces. And then number 27, it says, draw an arrow to represent the direction the golf ball will travel when it's struck by the club. So this golf club would swing back and hit this golf ball, which would cause it to go in this direction. So when an unbalanced force acts on an object, it's going to travel in that same direction. And number 28, blank forces cause a change in motion, and blank force do not cause a change in motion. So we said unbalanced forces cause a change in motion, and balanced forces do not cause a change in motion.